Okay, so in this video, we're going to look at some definitions of symmetry within a function. And the first type of symmetry we have is symmetry with respect to the y-axis. And that's called an even function. Okay, so you can see this function here, f of x equals x squared minus 2. There's a symmetry between the left side of the function and the right side. And the y-axis here acts kind of like a mirror. On the left side and the right side are mirror images of each other. Okay, so from a graphical standpoint, that's what it means for the left side and the right side to be mirror images of each other, and the y-axis here acts as the mirror. Okay, I also have written down the algebraic definition of an even function. F of negative x equals f of x, and we're going to look at that in a minute. But right now we're just going to sort of look at the graphical definition of the function. Okay. Now, in order to sort of explore and demonstrate the algebraic properties of an even function, I'm going to use my calculator, and I'm just going to type the function here, x squared minus 2, and I'm going to graph it with a standard window. Okay. So there you have it. And the reason I'm putting this into my calculator is so I can show you what I mean with the algebraic definitions here. So this means that if we put in a number for x, so let's say I hit trace and I enter in a value for x. Let's say I enter in 3, okay, the function is going to give me 7. Now, if I enter in negative 3, it's also going to give me 7. So f of 3 might be over here, that's 7. F of negative 3 is going to be on the left side. And if you notice, the y values of these 2 points is going to be identical. Okay? And that's what this algebraic statement is saying right here. F of negative x is the same thing as f of x. So in whatever number I enter in for x, let's say I enter in 2.5 or 0.25, okay, the function gives me negative 1.9375. If I enter negative 0.25, I get the exact same value. So if I enter in an x value and then I enter in the opposite of the x value, the y value is going to be the same in both cases. So from just an exploratory standpoint, that's why we can say this algebraic statement. And now a little bit later, we're going to look at how we can actually prove this algebraically. This is not a proof yet. This is just sort of seeing a pattern, using a little bit of induction here to say that this is probably going to work. Okay, and later in the next video, we're going to see how we can prove that this is true. So that is an even function. Now the next definition here is an odd function. And once again, we're going to look at the graphical interpretation of this first. And it says that it is symmetric with respect to the origin, or 0, 0. And so to illustrate, I have a function here, f of x equals x to the third. And I'm also going to graph this on my calculator. Let's see if I can put both on here. And you can see that there's the function on my calculator. Now, if I take this and I turn it 180 degrees, I effectively have the exact same function again. And so that's what we mean by symmetric with respect to the origin. If I take it and turn it 180 degrees, I end up with the exact same function again. And so that's the definition of odd. Now I also have an algebraic definition here. F of negative x is the same thing as negative f of x. Okay, if at this point, if you have some trouble interpreting what these function notation means, please go back and watch the video on function notation. Okay? So, and just to recap here, the reason why we have both a graphical description of these meanings of odd and even functions, and we also have an algebraic, is because they really serve the same purpose but in different ways. So it's probably more intuitive to look at the graph and see the symmetry. Okay? But the thing with the graph is that sometimes it can be deceiving and it's not an absolute proof. Now the algebra is a little bit more confusing. The notation tends to be a little messier. But with an algebraic definition, we can actually prove that it's true in all cases. And we're going to see that with a couple of examples of odd and even functions in the next video.